This is one of a series of lectures produced by the Further Mathematics Support Programme for A-Level Mathematics Revision. In this lecture we're looking at the Edexcel specification, Decision Maths 1, and this is the second of two lectures on algorithms. In this one we'll be looking at flowcharts and binary search. So the specification says you should have an idea of algorithms, and algorithms implemented by a flowchart or text. So usually these are given by a flowchart, although you may have a series of instructions which are written out in what are called line numbers. The binary search is one which looks at a list, either numerical list or an alphabetical list, and asks you to see whether or not, using the algorithm, a particular element exists within that list. Now, to do a binary search, the list is divided into two at its middle point, and then the element that you're looking for is either going to be to one side, it's either before that middle point or it is after. And so at each stage the list is divided into two, hence the binary part of the algorithm. The middle is defined by the formula in the specification, so the middle point is given by a half n plus 1 if it is odd. So for example, if n was equal to 5, we would have 5 plus 1, so that's giving us the third value. And it's a half n plus 2 if n is even, so if n was 6, we would do a half of 6 plus 2, which is the fourth. Another way of doing the same thing is to literally look at the list and say, well, where is the middle of a list? So for 5 elements, the middle appears right on top of the third element, whereas for 6, then the middle of that is between the third and the fourth element, so we actually use the one to the right, the fourth. So this is the difference between odd and even. The first question I'd like to look at is one based on a flowchart. And just reading through the question, we're told that the algorithm described by the flowchart is in figure 4, so that's the right hand side here, and that given a value of s equal to 25,000, we're asked to complete the table which is in the answer booklet. That will be on the next slide, to show the result obtained at each step when the algorithm is applied. Goes on from there, once we've done that, to say that the algorithm is designed to model a system of income tax on a salary S. So ask you to use your answers to write down the amount of income tax paid by a person with salary £25,000. Notice that is the 25,000 that we entered as S in the first place. And also to just check your understanding what's going on in the flowchart, saying find the maximum salary of a person who pays no tax. Well, looking at the flowchart itself on the next slide, we can see that what we have to do is to start and then just follow through step by step, inputting our values. So we've got the input, we have particular things to take note of. So to start off with, we're told that t equals 0, and then some calculations to be done. So the calculations tend to be in the rectangular boxes. We then come to what's called a decision box, and here we're asked, is r greater than 0? And depending on that decision, we either have yes or no, and we follow through to finally produce some output. So what I'll try now to do is to go through at each stage, showing where we are in the flowchart. So we're starting off by inputting value s, and that value of s we were asked to do was 25,000. So putting in the value 25,000 on our sheet. We're then moving down to look at t. T is equal to 0, so entering that on the spreadsheet, and then we have a calculation to do. R is equal to S minus 8,000, so 25,000 minus 8,000, so R has a value of 17,000. We then come to the first decision box. Is R greater than 0? Well, clearly yes it is, so yes is the answer. So we move on following the yes part of the diagram, and says T is 0.2 times R. So we've got to change now in T. At this point you may want to start using a line for each part of the flowchart. So the next change, T, is 0.2 R, and that turns out to be 3,400. Then R changes. In the next step, we take 10,000 away from R, so R becomes equal to 7,000. Then we have another decision to make. Is R greater than 0? Well, yes it is, so we're still at yes. So T then becomes equal to T T plus 0.15 R. So we've got to take 0.15 times the current value of R, which is 7,000, and add that to the value we've got in T. So we've got the T here, which is 3,400. We're then adding to that 0.15 times 7,000. So that gives us a value of 4,450. Then continuing down the flowchart, we've got another change to R to make. R equals R minus 12,000. So all that says is take the value of R at the moment, 7,000, and subtract 12,000 from it. If we do that, we get negative 5,000. And then we come to another decision box. Again, is R greater than 0? Well, no, it's changed now. So we're putting in here R greater than 0, no. So we've now got to follow, instead of carrying on down the chart, we've now got to follow through our chart to the right, and then follow down so that we actually come to an output. And we're asked to output the value of T. So at that point we output T, and that will be 4,450. And finally the flowchart tells us that we finished, and so we can stop the end there. Now the rest of the question was just interpreting that. So the first part is to say that therefore the tax on an income of £25,000 is equal to £4,450. The last part of the question asked, what was the tax-free, or what's the maximum amount you can earn without paying any tax? Well, that would mean that, of course, that T is equal to 0, and we'd have to go right back up here. The first point there is T equal to 0, and if we progress past here, we would get to some value of T, so we would have some tax. So we're going to have no tax if we have no at this stage. So what that's saying is, what's the maximum that our salary S can be if R is going to be equal to 0? Well, of course, R is equal to S minus 8,000. So we can say that there's no tax if S minus 8,000 is equal to 0, and therefore our greatest amount of tax-free allowance is £8,000 is the largest we can earn without paying tax. Now to look at the mark allocation for this, there's a method mark for getting the first row correct and coming up with then A marks once we get the 3,400 at that stage, and a second A mark we get through to the end where we've got the 4,450. There's also an M1, so a method mark, an accuracy mark at this stage for looking at the decisions down the road. So the further you get through correctly through the flowchart at this point, the more marks you will pick up for that. There's then a single B mark, so no method involved, for the value of the tax. So if you get that one correct, and then a second B mark for the largest tax-free value. The second question I'd like to look at is one looking at binary search. So here we have a list of names, as you see, Jenny, Mary, etc. down this list of 10 names. And the first part of the question says explain why a binary search cannot be performed with its list, within this list. We're then asked to use an appropriate algorithm to alter the list so that we can perform a binary search. And lastly, we're going to then use a binary search to locate Kim's name in the list, should it exist. Well, the first part of the question was asking about the list as it stands to have a binary search. It's not possible because for a binary search, excuse me, the list must be in order. Whether that be an alphabetical order or a numerical order. So the list has to be changed. Now the sorting algorithms are covered in a different lecture, so I'm going to assume that that sorting has been done. You could use bubble sort, but more likely than not a simpler method would be to use a quick sort, which is, as its name suggests, going to be a quicker method. However, whichever method you decide, it's not specified within this particular question, although often the method that you're asked to do for the sorting is specified. But whatever you do, you end up with the list as it is here in its alphabetical order. I've just abbreviated obviously the names with initial letters. Now we start off looking at the middle of the list. There are 10 numbers in here, so the middle of this list will be at 10 plus 2 over 2, which is the 6th one. And the 6th one in there is Jenny. Well, we need to say then, are we going to use that? Have we found Kim? Well, no, Jenny's not equal to Kim, obviously. And Kim is going to be, if Kim exists in the list, it would be in the second part. So we reject the left-hand side, the values of 1 to 6 of the list. Now what we've done then is immediately, well, sorry, not immediately, after that first one, we've reduced the size of the list from 10 down to 4, less than half in fact. The middle, we can either consider it as being a new list of size 4, so the middle would be 4 plus 2 over 3, the third one. Alternatively, you can simply use the numbers above, so the middle of that new list will be at 7 plus 10 over 2, which gives 8.5. Sorry, because that's odd, we need to add 1 to it, giving you again a value of 9. So the ninth one probably worth indicating there is our new search position. Well, Richard is not equal to Kim. In fact, Kim would be in the list beforehand, so we reject from Richard, which is 9 up to 10. Same thing again, we're going to look at our new list of K and M. So we look at the pivot being M, and we can say therefore Mary is not equal to Kim, so reject 8 in the list, which was Mary, to give K. And then selecting K with an only list of size 1, we found Kim. So Kim is found in our new list. And there we are, finished. The marking for this is relatively straightforward. There's simply a method mark for showing the middle of the first list there, an accuracy mark for this first part, and then an accuracy mark which is a follow through. So if you get the first part wrong and you reject the wrong part of the list, you can still get a second accuracy mark there. And finally, right at the end, a final accuracy mark. Do be aware that you must go through the algorithm as I've done it here, and that sometimes the thing that you're looking for may not be in the list. So you get to the end and you just say, I have not found the particular value that was requested. Okay, so that's the end of this lecture on algorithms for Decision Maths 1. You can find further information at the website www.furthermaths.org.uk, and also you'll find there information about other modules and revision modules that are available.